So today we're going to talk about how these angles can play a role, how we can find these angles based on certain rules that we've learned. Now, before we start, there are two words that you're going to have to recall or learn. The first one is the word parallel. And let's make it parallel lines. And these, by definition, are lines that will not cross each other. In parentheses, I'm going to put the word intersect, because that is something that we've learned already. So let's put it this way. If there are two lines that are parallel, then they are pretty much going to look something like this. I have two lines, and you can go ahead and draw this. And then now I'd like to point out that to symbolize that they are parallel, we usually use an arrow. Okay, so the arrow here shows that they're parallel. Now let's see another example of two sets or two pairs of parallel lines. So I'm going to draw two lines right here that are parallel to each other, and I'm going to draw two up and down lines right there. They're also parallel to each other. Now, sometimes what we do is we demonstrate that they're parallel with the arrow that we showed earlier. So let's say the two horizontal, they're parallel with each other. And to demonstrate the vertical ones being parallel, then we might do something like this, a double arrow. So the double arrow means like the double arrows are parallel to each other and the single arrows are parallel to each other. Now, why this definition? Because a non-example, let's write this down. Is a line that maybe slightly shifts upwards like this, and the other one maybe, let's say, just goes slightly downwards like this. Okay, that is not a parallel. And the reason why is because even though maybe to the right side, they might end up not crossing each other, but if you go the other way on the left side, you're going to find out if I continue this line and I continue the bottom line, that they will end up crossing each other. Right? So in other words, parallel lines, they are completely straight lines that are kind of like equal signs, and they will never cross each other at any point. So this right here, it's a little bit bent there. I kind of cheated a little bit, but that is a non-example of a parallel line. So that's the first word that we're going to cover. Then there is a second word, which is the word transversal. And we could say that this is a line that intersects multiple lines. So, for example, if we have two parallel lines, let's draw this out. And I have that parallel symbol. Then if I have one line that crosses them, then this is the transversal. All right, so why is this important? This shape right here will be one that we will revisit over and over again. You might even get images with even more lines, so just be aware of that. Keep that in mind. But let's get into this. So we're gonna talk about like which one are interior angles, which ones are exterior angles, and that's what we're gonna cover mostly for today. We're just gonna go with the interior, alternate interior and exterior, and then there'll be another set of notes for the corresponding. All right. So for the alternate interior and exterior, we need to start by labeling some of these angles. So let's just start with maybe something as simple as alternate interior. So an alternate interior angle would be if let's say we draw another one of these images and you said that there's a transversal that goes through them. Now, the interior angles will be what we will label as angle A, angle B, angle C, and angle D. So interior angles are angles that are inside this image. So in other words, it would be this angle right there, angle A, this angle right here, angle B, this angle right here, angle C, and angle D right there. All right, so they are inside the inside kind of the two parallel lines. They're between the two, right? You can see that they're interior. So interior means inside. Now, we know that there are some rules that we can come up with these. As you know that these angles right here, oh, I forgot to mention that they're parallel, so go ahead and add that. But you know that these angles are supplementary, so A and B are supplementary with each other, and so is C and D. What's interesting though is if you know some of these, let's see, if you know some of these angles, you'll find out that angle C and angle B, let's see, how do I put this? All right, so angle C and angle B, they're kind of opposite angles. So if I put some another imaginary angles, so let's say I'm going to add angle E right here and angle F, let's put it on this side. So now you'll notice that with these angles, they are generally the same because they're parallel lines and the transversal is one straight line that crosses them both. So you're going to see that all four corners of the angles are going to be exactly the same. That's because the angle of the line matches both parallel lines, even though they hit on different spots, but the angles are actually still the same. So what do I mean by that? Well, you could see that angle E here is very, very similar to angle B. You could see that, right? And then you could see that angle F is very, very similar to angle C. Now, based on this, we could tell that if angle C and F are the same, that means they are opposites with angles B and E. Now, based on that, therefore, we know that angles C and B are also the same. So let me just re-demonstrate this. So angle E and C, we could say, let's actually use black here. Angle C is equal to angle E. And we also know that angle F is equal to angle B. Now, because of their placement, we know that angle F is the same as angle C as well. So if these two are the same, that means these two must also be the same. In other words, all four of these angles are the same, based on opposite rule and all that. So because of this, we've come up with a shortcut on what we can call these angles. So we call these alternate interior angles. So alternate interior angles. And what we mean is that they are the same, but because they're alternate, or they're interior, they're all inside, and because they're alternate, then they would be all the same. So, in other words, angle C is equal to angle B, and I'll use caps like usual. There's another alternate interior pair. Before I go ahead and write this, can you find out what the other alternate interior is? Go ahead and try solving that. You could pause this for a second. If you're done, then you can unpause it. All right, so the other alternate interior that you would notice is the angles on the inside which is angle A, and is equal to angle D, okay? So these angles are also equal to each other. So if I give you something like this, let's see right here, how do you apply this? Let's say I have these two parallel lines, and I have this one transversal right here. Now let's say I know that this interior, that this interior right here is, let's say it's a smaller angle, so let's make it 75 degrees. Then can you tell me what would angle G be? Go ahead and try to solve that, and then we'll get back to this. All right, so it should be as simple as angle G is equal to 75 degrees. And why is that? Because of the alternate interior angle rule. Now, if you wanted to try this in a more longer way, or a longer approach, then you'll start by solving that. You'll know that this angle across must also be 75 degrees. And because this angle matches this angle because they're parallel lines, therefore G must also be 75. But as we mentioned, we already have a new rule, and that is alternate interior angles, and the fact that they are the same. So another way to remember it is the letter Z. Okay, let's think of Z. All right, and so what you can remember is if you had like a letter Z right here, assuming as long as these are two parallel lines, then you'll know that the inside of this and the inside of that are the exact same angles. All right, so with that, now we're going to add one more, and that is going to be the alternate exterior. So, all right, for alternate exterior angles, we should be able to draw something similar to what we did earlier. So we'll have the two parallel lines with a transversal that goes across both. And these are parallel. Let's remember to put that. Now, exterior angles will be, let's have angle H, I, and then J, and then K. So exterior angles equals angle H, angle I, angle J, and angle K. All right, so you could see that there's some similarity. These are the kind of the leftovers. Earlier we had angle F and angle E. That's actually an example that we're gonna have as well in a second here, but but this is what you'll need to look at first, right? So exterior angles, this right here means that they're on the outside, and you can see that they're on the outside of the parallels. So alternate exterior angles, let me just double check this. All right, so the alternate exterior angles, what are their rules? Well, alternate exterior they're actually an extended version of the vertical rule. So we could just say similar to vertical angles. So what do I mean by that? Well, in this case, we are saying that angle H and angle K should be the same. Now, how do I know that? Because I know that angle H and the one across from it, which is this angle right here, should be the same because they're vertical angles. And so if you notice, these two angles are similar to each other as well. And so therefore, angle H is equal to angle K. And there's another pair as well. Could you go ahead and try to see if you can figure that out? What are the other two angles? Oh, you should get that they are angle J and is equal to angle I. All right, so that's alternate exterior. So if I gave an example here, you have another one of these transversals. You have the two parallels. And there we go, parallel, parallel. And then let's say that this angle right here is going to be 125 degrees. What would angle Q be? And you probably would have guessed that angle Q is equal to 125 degrees because they're the same. All right, so that's kind of the rule that we are going to use in this case. Keep in mind that also we're dealing with supplementary angles as well. So actually, even based on this, you could find out what the other angles are. I would already know what this angle is, right? So this angle on the other side would be 180 minus 125, which should be 55 degrees. And from there, you're going to see that there's a repetition of these angles. So many different rules that you can use, but let's just use vertical for this one. I know it's 125 degrees. And if I subtract 360 from all these from 360, then I should be left with 55. Or I could use another vertical angle rule. And then this allows for all the other angles below to also be the same. So 125, 55, 55, and 125. All right. So you just have to do the try question on page 40, and please do number 1. Give that a shot. See how you do. Good luck.